All right, here we go with the next set of notes, this one on amphibians. In this set of notes, we're going to talk about the defining characteristics of amphibians, some of the different types of amphibians, and then we're going to take a closer look at some of their organ systems and maybe talk a little bit about how they compare to the fish, and then we can later compare other organisms to the amphibians. There are four defining characteristics of amphibians. First and foremost is that they have an aquatic and a terrestrial life stage. That's what amphibian means two lives, basically. Like ambidextrous means you can use both hands. So they have aquatic and terrestrial life stages, so they're still tied to the water, definitely for reproduction. Like when they lay their eggs require that water because they're just like a jelly mass. But some animals can spend, like the toad, can spend more time away from the water than like a frog or the salamander could. They all have moist, thin skin. They do not have scales, definitely no scales. We see those come later on. They don't have claws, even though sometimes it looks like it. You know, this looks like this guy might have claws, but just toes. And they can breathe in a variety of ways. They can use their gills, like this guy has some external gills. They can breathe through their skin, and they also have lungs to breathe for when they're living on land. There are three main groups of amphibians, or three main orders. The first one that you're probably most familiar with are the frogs and toads, and this is order Anura, which means tailless. A without, neura means tail in Greek. Most of the members of this group spend pretty much all their time in the water, but some can spend a little bit more time away from water. But again, they all need to return to the water at some point. The second order is Caudata, which means tailed amphibians. You may remember the caudal fin in the fish is the tail fin, and these are going to be the salamanders. And then the last group is order Apoda. So A means without, pod means foot. So these guys are things without any legs at all. They're called, the main organisms are called caecilians, and they're pretty much look like a legless salamander to me. So this guy looks a lot like a salamander, but he has no legs. It's not a snake, right? Not going to be a reptile. There's still skin. There's no scales on there, so not a snake. Looks kind of like it, but it's not. So continuing our examination of the circulatory system, these guys are quite a bit different from the fish that we looked at before. First and foremost is that these guys have a two-loop circulatory system. So you probably recall the fish, we talked about only having a one-loop circulatory system, went from the heart to the gills to the body, back to the heart, right? Well, these guys have two loops, so blood sort of makes two circuits. So it goes from the heart to the lungs or gills or whatever it happens to be, back to the heart, and then it goes to the body. Right, so it goes from the heart, goes to the lungs, picks up its oxygen, comes back to the heart, gets pumped again out to the rest of the body, back to the heart, and so on and so forth. And the advantage of this is that blood comes back to the heart where it gets sped up again. So it gets slowed down by the gills, or it gets slowed down by the lungs, but then it speeds up again later on. So it's a big advantage over what the fish has. And this is made possible by the fact that there's three chambers. There's a separate area where one chamber is pumping blood to the lungs and one chamber is pumping blood to the body, right? So you need that. The problem is with this third chamber is you kind of got the red arrows and the blue arrows, blood without oxygen and blood with oxygen is still mixing a little bit. So it's not really super efficient, but you do definitely get a big advantage of getting more blood flow. And then we already talked about some of this. The respiratory system is highly variable. They could have gills in the water, so for the young usually, but some things like the axolotl in the last page have those external gills. Looks like a fun hairdo. And then skin and lungs when they're on the terrestrial side. That's kind of like why I don't like you touching the frogs in the classroom. They're real sensitive because their skin needs to remain moist, and they can absorb a lot of stuff through their skin. Oxygen, obviously, but other things as well, like hand sanitizer or lotions or other things like that might be on your hands. So that's not very good for them. When we look at their digestive system, we can see that this is more advanced than what we see in the fish as well. The fish just had an intestine, that's it. These guys have more division in that intestine. Now they have a small and a large intestine, so two different things. The small mostly is focusing on digesting and absorbing nutrients, and the large is mostly focused on absorbing water. And then furthermore, that small intestine is divided up a little bit more, so a little bit more specificity, and into two different sections called the duodenum, or some people call it duodenum, and then the ileum is the other section. So a little bit more specialization in the digestive system. And then there's also a huge difference in the skeletal system of amphibians. These guys need bigger, more strong, robust bones to support their body on land. So if you think a fish skeleton is pretty wimpy, these guys have much more thick bones and kind of similar to what you are maybe used to seeing on yourself or lots of other organisms. And one of their cool adaptation they have is something called the atlas vertebrae. So this is the first cervical vertebrae, the first vertebrae of the neck. This is what actually supports the head. And you can kind of see where you have like this cup shape. And it supports the head and allows the head to make up and down movements. Basically allows the organism to nod its head. And this guy gets his name from mythology, Atlas holding up the world on his shoulders like this, kind of like this bone is holding up your world, your head, your giant globe, and allowing that to move around. So a frog can say yes. They cannot say no, though. They don't have the bones to do that. Those will come a little bit later. And with that, we are done with this set of notes.